How you doing, everybody? Randy Richard in the shop. Now what we got here is broken. That broke right off of there. So that's 2.5 inches or so. Threaded. A hole in here with like a bushing thing or something pressed in. This is about 8 inches across, 2 inches thick. So this pin goes up in there, and then it's been welded right here. It's been welded in. So after I clean it up, I think I'm going to go in here and remove that weld. I'll probably just go in and mill it out. I think I might be able to reach in there actually with a boring bar and cut it with a boring bar. If I can I'll put it in the lathe. Actually, the lathe thing might be the best. And we'll cut that weld out, drop that pin out. We'll get some measurements on things. See about stock and things like that. Yeah, maybe have to buy some material. And we'll get a new pin made. We don't know if this has been heat treated or not. It may have been, but it'd be more for if the other one breaks, they could use it as a backup type deal. So they're not too concerned about that. But they might be able to buy a pin even, but I have to get that one out at least. Anyway, let's go look at it. We're going to go around here and try to cut that weld out. Now, you can't see it, but from the camera view down in here, but I can see where the seam is between the pin and the piece here. Before I took this out of the mill, I thought I'd show you. So here's the pin. Here's some weld still, but right there is like a crack, and it's all the way around. And that's the seam between the pin and this base piece. So after close examination of here, that looked like the crack, but what it is, it's actually a spiral crack or spiral line. And I was milling away the end of the pin, and it goes from thick to thin, so it looks like that's the end of a thread. And then close examination of the other end, it also looks like the possibility of a thread. Then you look at the bolt or the stud at the other end of the stud that broke off. There is an undercut as a shoulder, but it's more like it's a thread. So I believe this is threaded in. There's a setup, a couple of 1/2 inch thick parallels underneath here because of the broken part of that is bulging out from the face. And that way I have room for the boring bar to go all the way through. A couple of clamps down and dialed in within a 1/2 thou all the way. So it'll be plenty close enough for what we're doing. Well, I'm pretty far out there. I think I'm going to stop and see if we can knock that thing out. Anyway, I'm going to just cut another groove on this side. It's really not very hard to saw, so it's not that hard. We'll do this. Then I might be able to knock part of that out of there. Oh yeah. Starting to move. There's a chunk. Threaded in. Pretty tough stuff. Yep, 2.5 inch. Threaded both ends. 12 threads per inch. Well, after some careful consideration, you know, I had measured the inside here, and because I know it's 12 threads per inch. I had measured the inside, so I kind of made some assumptions, and good thing I stopped. I also looked at the end of here. There's actually a shoulder here, and there's the thread right there, and that's where it broke off, right in the thread. I go, that is really, it is smaller than the 2.5 inch diameter of the pin. Well, I measured this and it's 2.230, so it's bigger than 2.25 inches. So I did some calculations with a 2 3/8 12, and it came out to be it came out close, but still not right. So I decided, well, I know it's 12 threads per inch. I decided I'd make a Delrin test plug, and after quite a bit of in the lathe, out of the lathe, you know, reacquired the threads about 3 times, and fiddling with this, I finally got the plug and got it right, and that it goes right real nice. It goes in there nicely. It's no real play in it, so that's good. It'll work out. So now I have a plug. It's an oddball diameter. It's 2.303 over the outside of the threads. I'm going to turn it to 2.305, make it a little bit big, but it's still 12 threads per inch. Anyway, I'm glad I reconsidered what I was doing there, and they didn't use a standard thread for that. On the end of this pin, it is standard. It's a 2.5 inch, 12 threads per inch. We got our piece of 2.5 inch diameter 4140 pre-hardened material in here. This is the same stuff I make the dovetail cutters out of. We're going to face this off, and then we're going to thread 12 threads per inch. Now I'm going to go in with a small radius tool. I'm going to radius these edges here. Looks good. Oh, a little snug in there, huh? Yeah. It might be. I'll have to make sure the threads are really clean inside the bore of this thing. I cleaned the threads, wire brush and stuff, and just touch the high spots on the peaks of the threads with a file real quick, and screws all the way on. Good deal. We got the shaft flipped around, dialed in. We're going to face it. We're going to thread it to here, that mark. Alright, it's been several weeks. We've finally been able to test the boss that will go in here. That's a spline boss we're going to put in to make sure it fit the hydraulic motor. So it fits and we're good. Now I left this a little long so I could adjust the length to with how much we're going to have the boss stick out and things like that, so for welding. So we figured that out. So I'm going to take off just a shy of a ½ inch off the end here. I'm just going to face it down. And then we're going to drill and bore it for the boss. It's really kind of long, so we're going to cut it about in half, basically cut it in half and fit that in. There's the hub we're going to put in. Now, when I measured it before, it had a sticker, big white sticker, about covered up 3/4 of this goes around it. And I, had measured it down here, and I measured it over here and outside the sticker. And I got 2 different measurements and stuff. And now when I take it apart, right here, you can see where they chucked it one way, turned it, flipped it around, chucked it the other way and turned it. There's a line right here. Yeah, you can just barely see that right there, right at the tip of the ruler. And so I measure over here, 1,378. Over here I'm 1,380. So it matters, if I want this to be like a light press going in there, I need to choose which side. So what I'm going to do is I'm going to take the small side because it goes down here farther. I need about half of this. I'm going to stick it in there about 1 inch, and I'm going to stick it out about 3/8 of an inch. So let's see here. That's right there up to the tip of my thumb. So I need about up to the part line. I'm about almost 1/8 inch shy of that part line. So I'm going to take the smaller side off and make it easy on myself. a pretty heavy spring pass, doesn't it? Yeah, that fits in there loose now. I only went in a little ways, about 3/8 of an inch. Maybe I'll just sand that a little bit and that'll be fine. We're going to weld it, so I think we'll be okay. Yeah, I'm at 81. So we'll just leave that alone. I'm just going to sand that a little bit. Just doing a little more weld cleanup since I didn't get it all out when I first removed the pin or the shaft. And I'm using the large boring bar I built, and it works absolutely wonderful in here. There's a part that goes in about halfway, and then it's going to press in the rest of the way. Looks just about right. Well, I think repair's done on this grapple swivel part, but I'm pretty happy with the repair, and I think it's going to work out just beautiful. It's dimensional wise, looks like, I mean, looks really, really good. I mean, as far as being right on the money. Thanks, you guys. Thanks for watching. Thanks for sticking with it.